Today we're going to be solving rational equations. And so when we're solving rational equations, these are ones that have fractions in it. And it's going to come back and play off a lot of what we did last chapter, where we found the LCM. But this time, instead of creating common denominators, we're actually going to multiply everything through by that LCM to cancel it out. So let's look at a couple examples of this. So let's first off, on all of these, the first step is going to be to find that LCM. And so our denominators we're going to list out separately. And then this 4 has an over 1. So our LCM, what is the most number of x's we had? Well, we had 1x. And then we look at the prime factorization of all the other numbers. So what's the most number of 2's? Because 2 is prime. We had 1, 2. So we're going to multiply by 2. What's the most number of 1's we had? Well, that anything multiplied by 1 is just 1. So that doesn't really change anything. So our LCM is just 2x. So let's go ahead and use that in this next part. So we have that 2x, and we're going to multiply 2x, technically 2x over 1, to each of these fractions. So 2x over 1 times 6 over x plus x over 2 times, that was supposed to be the purple, and we're multiplying that by the 2x over 1. And it really doesn't matter which side of it you put it on. And then equals 2x over 1 times that 4 over 1. And that's the same thing. So on this other side, because they were both over 1, you didn't have to rewrite it with a 1 in the denominator, but if you did, it's just fine. So we're going to go ahead and multiply everything through. So 2x and the 6 and times 6 over x, what can cancel? Well, the x's can cancel. And that leaves me with 2 times 6, which is 12, plus 2x over 1 times x over 2. Our 2's cancel, so x times x is x squared. And on the other side, 2x times 4 is 8x. Since you have a squared term, that means you need to get everything to the same side and solve that equation. And you're going to use factoring or quadratic formula. And so I'm going to rewrite this in the best form, which is a squared term first. Then if you have a b term, put your b term plus your c term equals 0. So I'm going to use the box to factor this. And the 12 goes here, the x squared goes here. So what multiplies to give me 12x squared, but yet will add to give me negative 8x. So that's negative 6x and negative 2x. And so when I factor that, I end up with x coming out of this first column and negative 6 coming out of the second. So, and then on the second one, I have an x that comes out of the first row and a negative 2 that comes out of the second row. So you're going to set each of those equal to 0 and solve. So x minus 6 equals 0 and x minus 2 equals 0. And when we solve that, we come with x equals 6 and x equals positive 2. Now, the last step is to check these answers to make sure that they don't give a 0 in any of our denominators. So the only way I can get a 0 in my denominator is if I had a 0. So these are going to work. You're checking for extraneous answers is what you're doing at this step. And so the extraneous answers are going to show up whenever the 0 is in the denominator. So let's check this. Let's solve this one. So step 1 is to find our LCM. So I have x minus 3, x plus 3, and these are both factored as far as I can go, so I don't have to do anything else with those. And then I have x squared minus 9. I need to factor that. So x squared, negative 9. So negative 9x squared. What multiplies to give those? To give us 0x. That'd be negative 3x and positive 3x. First column is x. Second column is positive 3. First row is x. Second row is negative 3. And so I have x minus 3 times x plus 3. So I'm looking at these 3 spots and I'm trying to find the LCM. So I'm going to take each binomial and identify what is the most of that I have. So what is the most number of x minus 3s I have in any one column? Well, I have that 1. What's the most number of x plus 3s I have? I don't have anything with higher than a first power. So my LCM is x minus 3 times x plus 3. So the next step is to multiply everything by my LCM. Over 1 times x minus 3 divided by x minus 3 plus x minus 3 times x plus 3 over 1 times what was there was x over x plus 3 equals x minus 3 times x plus 3 over 1. And I'll go ahead and write out my denominator factored that we just found on the previous page. You don't ever have to worry about factoring your numerators. Don't do that because it will make you have to work extra hard at a step. But always factor your denominators. So what can cancel is the binomial of x minus 3 in the first set. In the second set, the x plus 3. And then the third set, both of them can cancel. It should, by the time you're done with this, you should clear all denominators. And so in this first set, I have x plus 3 times x. Had addition between them. In the second set, I had x minus 3 times x. And in the third set, everything canceled but the 2. So I'm going to distribute and combine like terms. So I distribute the x to both pieces, and I have x squared plus 3x. And distribute the x to both pieces, and I have x squared minus 3x equals 2. So now I need to combine like terms. These two are going to cancel, and I end up with 2x squared equals 2. Remember that plus 3x minus 3x equals 0, so those cancel out completely. Now I need to solve for my x squared. So I need to divide both sides by 2. Oops. X squared is equal to 1. Now I need to take the square root of both sides. And remember, when you're taking the square root, it always creates a positive and negative result of whatever it is. So x is equal to positive or negative 1. The square root of 1 is 1. So if I plug a 1 back up here, 1 minus 3 is 4. 1 plus 3 is 4. Or excuse me, 1 minus 3 is negative 2. 1 plus 3 is 4. 1 squared minus 9 is negative 8. So that didn't cause any problems. Let's do the negative. Negative 1 minus 3 is negative 4. Negative 1 plus 3 is a positive 2. Negative 1 squared minus 9, that's going to be negative 1 times negative 1, which is positive 1, minus 9, so negative 8. None of those created a 0, so it's going to work with both solutions. Let's try one more. So first off, we need to find our LCM. If you notice, the only denominators we have is at 2k, and this is over 1. So our LCM is just very simply 2k. If the denominator was the same all the way through, you just get to pick the denominator. So I am going to multiply 2k over 1 times each of those items. K plus 2 over 2k, and 2k over 1 times 1 over 2k minus 2k over 1 times 1 over 1. And so when I multiply it and look and see what can cancel, my 2k can cancel, my 2k can cancel, and then so my numerator on that first one is left at k plus 2. My second one is a 1, because 1 times 1 is 1. And on my third one is 2k. So I don't have a squared on this case. That means I'm not going to have to factor. I just need to get the k's on the same side, and then the numbers on the other. So I am going to add 2k to both sides, and I am going to subtract 2. So that leaves me with 3k is equal to negative 1. Divide both sides by k. Excuse me, by 3. And I end up with k is equal to negative 1/3. If I multiply negative 1/3 times 2, I'm not going to get a 0. So that means that is a solution that checks. I want you to do this next one on your own and see if you can come up with a solution. So check it with the one that's in Edpuzzle, and then I have the work on the next page. You should have come up with it being 7/3.